CPU scheduling. Now, what is the CPU scheduling? Let's go into a brief introduction about it. CPU scheduling is the responsibility of the operating system. What is that? We assume that there is only one process, and this one process will be managed by the operating system. And how this operating system is to manage it? It will manage it to find it out which process will get the CPU, which process will be exited from the CPU, and how much time will provide the CPU for a particular process. All these things will be managed by the operating system. And the CPU schedule, the module which will do the CPU schedule, which is called CPU scheduler. So it is the responsibility of the CPU scheduler to allocate the CPU to any process. And we know that if we'll talk about program or uni-processing operating system, so there are only one process which is running at a time. But we say that particular concept and we'll make the concept as a multi-programming operating system, okay, or multitasking operating system that we can make. But ultimately, there is one CPU, and there is only the condition like the CPU will execute one program at a time. So let's go and try to understand what are the different parameters related to a process when we talk about CPU scheduling. Now here we have some important parameter of the process. Before going to the CPU scheduling, we just see what are the different parameters related to the process. So the first is the arrival time. Arrival time is the time when a process will be allocated the main memory. It means when a process is in the ready state, okay? That particular time is called arrival time. What is a burst time? Burst time is the time duration where it required the CPU. So let's say we have a process and this particular process required 5 units of time. It means that 5 units of CPU time. It means that this is the burst time of the process. So process require 5 units of CPU time. It means that for that particular time, it required the CPU for executing its instruction. So that particular time is called burst time. Next time is called completion time. So we know that different states, right? So we have new state. From the new state, a process will go to the running state. From the new state, the process will go to the ready state. From the ready state, the process will go to the running state. It means it will allocated the CPU, and then the process will be terminated after running its instruction. So new state is in the secondary memory. Ready state is in the main memory. It means that once a process will be allocated the CPU, means is in the running state. That is called arrival time. So let's assume that this is the arrival time. Running means how much duration it is taking in the running state. That is called burst time for a process to terminate. And completion time is the time duration when a process will reach to the terminate state. So when a process reach to the terminate state, that particular time is called completion time. So here this is the time instance, this is the time duration. Arrival time is also time instance. So I think you understand what is the meaning of time instant. Let's say the arrival time of process, let's say P1 is, let's say 10 o'clock or 10. So what is the completion state or completion time of that particular P1? So you assume that it will be 10:15. So how much time it is taking in these all these states is 15 minutes. What is the burst time? Burst time is 5 minutes, let's say, or 5 unit. Okay. So you see that the completion time is this one. So completion time we are talking about, it is not a duration. So completion time when a process reach to the terminated state, that is called completion. Now the next time, which is called turnaround time. Now what is a turnaround time? Turnaround time, which is in short we can say turnaround time. It is nothing but completion time minus arrival time. So what is the turnaround time? So turnaround time is here we have 15 minutes. This is my turnaround time. What is it? This is the completion time. This is the completion time. And this is the arrival time, right? So the turnaround time is nothing but completion time minus arrival time, which is what? This 10:15, it is in termination state. 10 o'clock, it is in arrival state. So what is the turnaround time? Is 15 minutes. So this is a turnaround time. Now there is another way how we can define turnaround time. So turnaround time is nothing but it is a duration, time duration. Okay. Next is waiting time. Waiting time means how much time a process spend in the ready state. Okay. How much time a process state in the ready state means how much time, after how much time of arrival a process will get the CPU. That particular time duration is called waiting time. Okay. Let's say you went to a doctor and there is a queue in which you are sitting. Is based on your arrival, there is a queue. So let's say you are patient number 10. So you have to wait till patient number 9 will be served by the doctor. Then only you will get the chance. So let's say the clinic is opening at 8 o'clock, 8 a.m. Okay. This is the opening time of the clinic. Now when you reach at your time. Let's say you reach around 10 a.m. Why your time? Because your number is 10. An approximate time given by the reception to you is 10 a.m. So you come at 10 a.m. So what receptionist assume that 9 people will be served in 2 hours, right? So let's say you came at 10 a.m. and you see that there are some people who are still waiting there. So what you do? You are going to also wait here. That particular waiting queue is nothing but ready queue or the ready state. So we don't know when you came. Once you came, that time is called arrival time. Means you came at 10 o'clock and you join them in a ready state. Ready state means ready to get served by the doctor, right? So how much time you are waiting here? So we don't know, right? So you came at 10 o'clock, maybe three people will take half an hour. Maybe they are taking half an hour. So what is your waiting time? Your waiting time is half an hour. So once you will get the CPU that particular time, and when you arrive that particular time, we'll do the minus. So let's say you got the CPU at 10:30. So what is the waiting time? Waiting time is nothing but when you get the CPU, that is 10:30, minus when you came, that is 10 o'clock. That is your what? Waiting time here, okay? That particular formula is going to work for a particular type of scheduling, CPU scheduling, okay? For other type of CPU scheduling, we have to look for all the time that you have spent into the ready queue. What are the other scenario? The other scenario is like this. So there is a doctor. So you assume that doctor is nothing but CPU. And there are patient. You assume that these patient is nothing but process in the ready state. So let's say this is 1, this is 2, this is 3. So process 1 will be getting the CPU, means it is getting the doctor. Doctor inspected, and after some time, doctor tell that particular patient that you give your blood to the receptionist. She will test it, or she or he will test it and give the result. So on that duration, you will wait. Once your report will be given, you will be called again. So that process who is going to the CPU again has to be come into the ready state. So again has to be wait. So the same scenario happened to the CPU. When a process is terminated from the running state, why? Because there is a scenario, maybe there is a high priority patient that can come into the doctor's chamber, that he need medical attention just now. So what doctor will do is, doctor will stop the diagnosis which is doing for a particular patient and tell him to wait into the queue, and the high priority patient it will take into the chamber and it will diagnose. The same thing happened to the CPU. The CPU is going to take the high priority process when it will come into the existence, and the low priority process it will put into the ready state again. This is one scenario. The second scenario is, maybe doctor is taking 10 minutes for diagnosing a patient. If 10 minutes is over, the doctor will tell him to wait in the queue again, so that he or she, the doctor can serve more number of patients. So in that particular scenario, what will happen is, the patient who is coming at 8 o'clock, if its diagnosis is not finished at 8:10, if diagnosis is not finished at 8:10, the patient has to wait again. The patient has to wait again. So this might be the scenario. And the same scenario might be with the process. So in that, the waiting time we have to calculate. Okay, so I think you know what we mean by waiting time. Waiting time is nothing but the time when the process is waiting for the CPU to allocate. Now the next thing is, or how we can calculate the waiting time, right? For the waiting time also we have a formula. That formula is turnaround time minus burst time. Means how much time it has allocated the CPU and how much time the process is there in other states is called waiting time. Means if a process is in the ready state, so how much time it will be in a ready state, that will be calculated by turnaround time minus burst time. So how it will be done, you see the formula. This turnaround time is nothing but completion time minus arrival time. That is also calculated as waiting time, that how much time it is in the ready state, it is your waiting time, plus burst time. Plus burst time is also called turnaround time. So waiting time will be calculated as turnaround time minus burst time. Are you understanding this formula? It is calculated by this particular formula or this particular equation. So turnaround time can be calculated as completion time minus arrival time. So whatever the time is within the turnaround time. Turnaround time is also calculated as waiting time plus burst time. So waiting time will be calculated as turnaround time minus burst time. So whatever variable we know, we just use it to find it out the value of other variable. Now the last one is the response time. Now what is the response time? Response time is the time when a process will allocate the CPU first time. Okay. So when a process will get the CPU first time, that time is called response time. Means a process will be responded by the CPU, right? So it is not like the second response also will give it. Like there is a doctor scenario, like doctor has got the patient into the clinic at 8 o'clock. So that 8 o'clock is the response time for that particular patient. Maybe this particular patient has responded at 8:10, because at 8:10 this patient has been going out from the chamber and this process is going into the chamber. So it is at 10. So at 10 is the response time for this particular process or this particular patient. Are you getting it? So what is the first response, or what is the first time when a process will be allocated the CPU? That time is called response time. So I think you all understood different time related to a process.